going to take a look now at nonlinear systems of equations. It says the perimeter of a rectangle is 50. The area is 156. Find the dimensions. Now, the units aren't given, but it really doesn't matter. We're going to go ahead and find it. It says to solve. So let's take a look. Oops. We're looking at nonlinear systems of equations, and that just is exactly what it says it is. It means that I might have, let's say, a circle. Might have an equation of a circle, and I might have another equation that's a line, and I would be looking at two answers. The places where, those two figures actually share space would be a place where they intersect, and that would be the solution to both of them. And we could even have something that looks like this, a circle intersecting a hyperbola, or an ellipse intersecting a hyperbola, and you would actually have four answers, right? So it would be these four answers. So if I have a, let's see, one other one, a parabola intersecting a circle, I could actually have that happening three times, right? Once, twice, three times. So anyway, we're going to have more than one answer to these. So this is an example of having two answers, and it's going to be, you know, a real-life application of these nonlinear systems. All right, let's take a look at a rectangle. And we know about the rectangle these things. That we know that the perimeter is 50, the area is 156. So I'm going to go ahead and identify my variables. I'm going to call, I'm going to call x the width. It's always a good idea to just identify the variables with words, and this is going to be the length for this particular situation. So let's go ahead and create an equation with this perimeter. So I have 2x plus 2y would have to be the 50. Now that one is a linear equation, but the next one is not going to be a linear. The next one's going to be a rational equation. So let's take a look at this one. The area is 156. Now area, let's go ahead and label this thing. Here's my width. I'm going to call this the width, and I'm going to call this the length. Well, the area is found by just multiplying the width times the length, right? So when I put the second equation on, that's just going to be x times y, and that's going to be the 156. Now that green one right there is not a linear. That's not a line. That's a rational equation. And so I'm going to do this. I can't add like terms. I can't solve this by elimination, things like that, because I don't have like terms on each equation. So let's do this. Let's just take the green one and solve for a variable. And I'm going to solve for y. I'm going to solve for y. Here I go. Get the x, divide by that, and y is going to be 156 over x. Alright, so now I'm going to bring this other equation down, and I'm going to go ahead and write it, substituting in for the y. 2x plus 2, leave some space for 156 over x, and that has to equal 50. Alright, let's just get this cleaned up a little bit. Oops, I'm going to have to insert a little bit of space here. Just a second. Sorry about that. Okay, so what we have is we have 2x plus, looks like that's going to be 316. That is not correct. 312, pardon me, 312. Okay, over x is equal to 50. And what I'm going to have to do is I'm going to have to get a common denominator, right? This is over 1, and I'm going to have to get a common denominator. So watch what I'm going to have to do. I'm going to multiply the bottom and the top by x over here, right? That's multiplying by a funny form of 1, and that's going to allow me to have a common denominator of x. So now I have 2x squared over x plus 312 over x, and that's equal to 50. Okay, getting this cleaned up. 2x squared plus 312 over x is 50. Now that's going to be considered a fraction. I'm going to use cross products, and I'm going to get 50x is equal to 2x squared plus 312. Now when I go ahead and get everything on one side, I'm going to go ahead and move this to the other side. So I'm going to have 2x squared minus 50x plus 312, and that's equal to 0. Now, I could try right now to start to factor that, but I am not going to do more work than I need to do, so I'm going to divide by 2, just because all of those can divide by 2 easily and nicely. So I'm going to have x squared minus 25x plus 156. When I factor that, I get this, x minus 12, x minus 13. And let's go ahead and finish this up. This means that x could be 12 or it could be 13. Now what does that mean for our picture? Let's look up here. Well, let's go ahead and find out what would happen if we substitute that back in. Okay, I'm going to go back into this equation right here. Okay, so I'm going to bring that back over here, pardon me. So I have 12y is equal to 156, and that gives me y is 13. Okay, well, it looks like then if x is 12, y is 13. Well, what if x is 13? Well, of course, you can see that y is going to then be 12. So it really doesn't matter that it could be 12 or 13. My dimensions that they wanted me to find the dimensions. The dimensions are 12 by 13. Now let's just double check and make sure that works. The perimeter is 50. If I have 2 of those and 2 of those, indeed it equals 50. And if I multiply the 2 together, indeed it gives me 156. So that I've just solved the problem. Okay? Alright, so let's take a look at another example of nonlinear system of equations. Alright, it says that a 64-inch TV has an aspect ratio, that should be an aspect ratio of 16 to 9. Find the length and width of the television to the nearest tenth of an inch. So let's take a look. What in the world is an aspect ratio? That just means the length to the width, right? That's the ratio of length to width. And a 64-inch TV, you're saying, well, don't you have the dimensions? No, 64 is actually the diagonal. When they talk about a 64-inch TV, or that would be the diagonal, a 50-inch TV would have a 50-inch diagonal. So we're going to create 2 equations. And we know, of course, that this is a triangle. We're going to use the relationship between 2 sides of a triangle and the hypotenuse. So let's take a look. I'm going to let x be my width, and I'm going to let y be my length. Oops, length. Alright, so then I have x and I have y. So I'm going to set up an equation. X squared plus y squared, this is the Pythagorean, right, is equal to 64 squared. There's one equation. Now, this right here, the aspect ratio, is going to be my other equation. So let me change colors here. And that's a ratio, meaning a 16 to 9. Now we're going to put in some variables, right? So let's take a look. I have 16 to 9. That's the very same thing. We make a proportion 16 to 9 as y over x, right? Because this is 16 is my length, so I'm going to put the y in that position. Okay, so I have my 2 equations with 2 unknowns, and I can solve it. And as you can see, this is certainly not 2 lines. They're 2 equations, but they're not lines. Okay, let's take a look at how we'll do this. Alright, I'm going to go ahead and erase the picture of that, and we'll put that back up in just a minute. So let's take a look. I'm going to go ahead and start with the blue one, and I'm going to have 16 over 9 is equal to y over x. I'm going to use cross products. 9y is equal to 16x. And I'm going to go ahead and just solve for x. Solve for x. Oh, heck, I'll just solve for y. Let me do that, right? That's what most people are used to doing. So I'm going to have y is equal to 16x over 9. Now, I have one variable isolated. Now I'm going to substitute it into the other equation, which is x squared plus 16x over 9. That's squared. That's what y is, and that's equal to 64 squared. Okay? So we get x squared. When we square this fraction, we get 256 x squared over 81, and that's equal to this big old number, 4096. Now, once again, I have to get a common denominator, and this right here is sitting at a 1. We know that that means I'm going to multiply by 81 over 81. That's multiplying by a funny form of 1, and that's legal. So I'm going to have 81x squared over 81. Oops, let me just go ahead and make it all one fraction. We know that we could add it. So that's plus 256x squared over 81. All right, let's see. So we get 337x squared over 81, and that's equal to 4096. And that we're going to put over 1 and use cross products once again. Okay, I get this. All right, so I'm trying to conserve a little time here, so I'm going to head and show the next step. So we're going to divide by, we're going to divide by 337, divide by 337, and I have x squared is equal to 984.499, we'll call it. I'm going to square root it, and I get 31.4, we'll say, and that's plus or minus. Okay, now let's think about it. Could the dimension be negative? Of course it couldn't be negative. So I know that x is about 31.4. Okay, and that's inches, right? So now how am I going to find my other one? I can come right back up here and plug it in. So y is 16 times that all over 9, and we get that the other dimension, we get that that's 55.8 inches. So our TV with a diagonal dimension of 64 inches is roughly 55.8 by 31.4 inches. All right, I'm going to wait till the next video to finish up the third example, so tune in for the last one. Thanks a lot.